Just to start things off, I just want to start with maybe an error some of us have seen before. NixOS, it's great for running software. It's not always great at running random pieces of software that you might found on the internet. So I at least, um, first started running into things and seeing cannot execute. Required file not found. What file wasn't found? Don't know. Doesn't say. Actually, Nix these days makes it a little easier for you. But this and sort of the discovery, the looking under the hood that this drove me to is kind of the focus of the talk today. You're going to hear a lot, and you already have from folks who are using Nix at work and doing all kinds of crazy stuff with AI or stuff in all kinds of embedded environments, all sorts of stuff. That's not this talk. This talk is what you do at home after hours when you want to just dig deeper. You're not trying to get something deployed right now. You just want to make sure that you actually understand what's going on under the hood. So this talk is Nix Anywhere Else, relocatable binaries via ELF surgery. I'm Wes Payne. You might know me from the podcast Linux Unplugged with me and the Jupiter Broadcasting people. Every Sunday, we're live. Go to jupiterbroadcasting.com if you want more of that. I'm also a software engineer doing Clojure, functional programming, distributed systems, and now breaking my OpenClaw seemingly every other day. So come talk to me about that, or jazz, or quantum physics if you like. There's all kinds of fun stuff. And of course, Nix. So to dive in, you might know this pattern. You try to run some random app, error while loading shared libraries. Lib standard C++.so, and then some random number at the end that probably doesn't mean anything, or you hope that it doesn't mean anything. Or maybe you're trying to run a Python project, right? You're finally trying out NixOS, but you have a Python project at work or something you found to integrate with a new API, and well, you try to use a standard Python library, something like NumPy or SciPy or anything that's kind of popular that isn't just a pure Python package. And what happens? You get another obscure import error. libz.so cannot open shared object file, no such file or directory. Or you want to go try to run some pre-built tool. It doesn't always work. Now, there are really good patterns and answers to this. And the usual answers involve something like nix-ld or nvfs, or you combine those things. And I'd like to be clear. Do these things first. Don't do what I'm trying to do to solve actual problems. People have already, much smarter Nix contributors already solved a lot of these problems. And if it's just kind of like dealing with, can I run this binary not meant for NixOS that doesn't have a bunch of complicated dependencies, nixld, nvfs, they'll solve it for you before you have to do anything manual. But it doesn't necessarily teach you why the existing stuff without them doesn't work, or how you can make it work, or if these tools didn't work, how you would solve it for yourself. So first things, ELF. It's executable and linkable format. We're not going to dive in. There's a bunch of folks, maybe go talk to Ilko if you can find them today, that know a lot more about ELF than I do or we need for this talk. But when you have a Linux binary, and we'll focus on Linux because, you know, NixOS, when you have a Linux binary, of course there's actually the assembly, right? The compiled instructions, the stuff that your CPU is going to somehow magically execute for you. But because computers, there's also metadata, right? There's always metadata. Sometimes there's more metadata than actual data. So there's a lot of metadata in ELF. We do not need all of that metadata for today's talk. And we don't really need to think about the bytes on disk. But what we do need to think about is it's a place to set some key value pairs that help Linux actually be able to run your binaries. So first things, right, we're talking about dynamic binaries here. You can't have a static binary where the compiler and the linker help you out at a static pre-chosen time right at the start, bundle everything together. But if you've run Linux anytime in the past 20 years, you know that if you're not using something like Alpine and Musil, or maybe some modern Rust and Go stuff, is often harder than it might seem. And we live in a world, whether we like it or not, of a whole bunch of dynamic libraries that get loaded when your program executes. Not when it gets compiled, but when it executes. And on traditional Linux distros, that often means it goes hunting under /user/lib for whatever it's going to find there. Now, of course, we know on Nix, we do things a little bit better, right? We have hermetic packages, and we have custom store paths that tell us just the right library. But whether you're on Nix or you're on Ubuntu, the kernel doesn't know about any of that stuff, right? It needs to know how it's actually going to execute this program that wasn't really fully compiled. So the first little bit is the interpreter. Who loads me, right? There needs to be some kind of file that's going to run things. It's going to know how to execute. And crucially, it's going to know how to pull in all those dynamic loaders. The kernel doesn't want anything to do with that, right? It just wants to run a binary. So something else, usually from libc, needs to get involved to go pull in all those extra dependencies. But where do you find them? So first we have our interpreter. That's what we were just talking about. Next up, we have the R path. And this is just answering the question, like, what folder do I even try to look for to go find all the libraries that I need for my program? That's the R path. And then after that, you have what actual dependencies you need. So in this case, we have an example with libz and SSL and some standard stuff from C++. So those are all metadata that get attached to all of your executables, or at least most of them, that you're running. And you have some handy tools to read them. You might check out stuff like readelf, which can be very handy, although it prints out a whole bunch of stuff. But if you do some grepping or get it as a JSON data structure, you can see it'll tell you, like, oh yeah, I expect to load an interpreter under /lib64, at least if you're not on NixOS. You can also use LDD, which will help you do the same thing. And all of these are just great ways to start exploring, but they're kind of read-only. But you will start running into them, and we ran into them just messing around last night before the conference, in fact. We've been at Jupiter Broadcasting, we've been playing around with some of these new open source agents like OpenClaw and associated projects. And if you've ever used Google Workspace, you probably know that configuring it and getting it set up and trying to use it is maybe one of the most painful things known to mankind. It turns out just recently, Google, trying to help folks out, has finally released a new workspace CLI. And not trying to represent Google, use them, don't use them, whatever. But it was a tool that would finally let us automate some more of the stuff we do behind the scenes anyway. And we wanted to try it. But of course, we all run NixOS. And so we go to the GitHub page, and we download the precompiled, it's written in Rust, it's precompiled, it's ready to go. And what happens if you try to run that on NixOS? Well, it's not going to work. I mean, if you use NixLD, etc., it will. But if you just try to run it on Nix, it's not going to work. Now, of course, this was pretty great. It was 9 p.m. last night. We should have been getting ready for bed. But we were messing around, and I was trying to wrap it with a little flake so it would work on NixOS. And as we were doing that, it turns out Google was merging a PR at 9 p.m. to add its own flake.nix to the repo. So I didn't really need to do that. They're doing it upstream, which seems perfect for PlanetNix and is awesome. And we need that really everywhere that we can. But it kind of made a good little thought for me is, okay, that's what you should do. Go use the upstream stuff, right? They're going to have it. But what is that? How is that shipped? Right now, they don't have their own cache for it. And that means you're going to pull down like 2 gigs of cargo dependencies just to build the binary that ends up being, 10 megs on your file system. And if you want trust and you want to do it right and you want to be secure, that is what you should do. But a lot of us, you might just want to be able to use the gosh darn binary that's on the GitHub page so you can try it out and then decide if you really want to commit to it. And that's what using and playing with tools like patchelf can let you do. Here's just a little comparison to show a little bit more of what you might see on NixOS or a standard distro. So if you do go download a random binary on a standard distro, maybe something like Ubuntu, it's going to be able to figure things out. It's going to go take a look and say, oh, I need to find libgcc. I need to find libm. I need to find libc. And it's already set because most distros put these in the same places to go find it under the magical, shove all of your libraries in one place and just hope for the best strategy that we've been using for like 20 years. Well, probably longer. And on NixOS, by default, you just get a whole lot of not found. And that's where we have a new friend. And that friend is patchelf. We had readelf, we had LDD. These are great for spelunking, figure things out, taking a peek under the hood. But, I mean, come on, we're hackers, right? We want to break stuff. And that is where patchelf comes in. It's been part of, it's been a helper around for Nix since, I guess, 2004, a long time. It is kind of instrumental to a lot of what Nix ends up doing. And it lets you actually just muck with that metadata, right? If you can think about it as a complicated set of bytes on disk, but if you just think about it as key value stores in a dictionary, patchelf lets you go set some of those fields, and not on the next binary that you're going to make, on the real binary that you have right now. So you can do stuff like set the interpreter. You can do stuff like change where it's going to go look for libraries. And you can even, add extra stuff. You want to say like, oh, well, the person who made this didn't realize, but it actually needs more libraries than it has. You can do that. There's also in Nix packages, which we'll make use of, the great auto patchelf hook, which can take care of a lot of this for you. It's smart enough to go look in whatever your Nix environment is. It goes and sees all the libraries that might need to apply, and it can automatically sort of fix things up for you. So it's a great little hack. You don't necessarily need to use it for everything we're doing today, but if you're doing anything actual, you surely would. Okay, so here's just a little before and after of what you can do with patchelf. Before, not found. And now, auto patchelf and patchelf can fix all those things up for you so that they know where all the arcane paths in the Nix store, and it knows actually the right library to find, and it won't just blow up on you. And if you do it in this way, where you let auto patchelf do it, and you do it maybe as part of a flake and a proper Nix package, then Nix can track that too. The garbage collector won't, steal them out from under you. It all just works. And this comes in very handy if you've ever tried to make Python work on NixOS. And don't get me wrong, right? Nix packages, lots of great Python stuff, tons of things are packaged, you can just run it. It's really one of the best ways to try and ship Python dependencies. But that's kind of for projects that, maybe they're well packaged by a Nix packages contributor, or it's something you have full control over, so you can kind of choose, I'm going to make sure I use the dependencies that are already in Nix packages. But for me, coming from a background of doing application development for SaaS companies, running websites, we weren't trying to build real Python packages. It all ran in Docker anyway, right? I was just trying to get Python that had all the libraries that I needed in a Nix environment, ideally with a dev shell that could work. I didn't need to muck around with all of the actual Python native packaging stuff. I had Nix for that. And Python packaging itself has improved. There's UV on the scene these days. That's getting better. It's a lot faster. So it's pretty easy. Nix has a lot of Python versions. So you can just do something like, pip install NumPy. Except if you do that, it doesn't work. Because, of course, Python packaging, it solves packaging for Python. It doesn't solve packaging for all of the standard libs and the Fortran libraries and the Rust stuff and the C libraries that it turns out Python uses to get most of any of its stuff it needs to do fast done. Nix can help with that. Now, what you probably do, and what most stuff does, and what you'll see in upstream Nix packages, is you essentially set LD library path. And that helps the binary run and tells the dynamic linker, hey, I know it says one thing here, or you don't have any info. Let me help you out. Here's an environment variable, a little crib sheet. Take that, go look there, you'll figure it out. And that totally works. You can use the neat wrappers, make wrapper in Nix packages library. It'll do that for you, so every time the binary runs. But if you don't want to do that, especially if maybe that's not especially dynamic, you're in control of the project, you only, I don't know about you, but I don't add a new native C library dependency every other day when I'm working on a Python project. So it's probably a core set of stuff that you might actually need. And there's another way. Instead of patching the actual patient, instead of doing operations on every single little random.so file that you need or making your own custom libraries, sometimes what I've started doing is I just use patchelf to tell Nix I want those extra libraries all the time. I don't want to wait till you actually try to run it to figure it out. What you can do is you can use patchelf and you just tell it, hey, I know you don't think you need libc. I know you don't think you need a bunch of stuff from C++, but it turns out you actually do. And when you do that, auto patchelf takes care of the rest. So I can just say, I don't even need to be super specific about where to find it in the Nix store, all the path stuff. I just say, hey, add libc, add lib standard C++, and then when this builds, patchelf will go find the right paths, go use it, auto patchelf takes care of hooking it up, and you end up with a binary that actually works. And what's great about this is you can just have this one Python interpreter that you ship around. Nix is going to make sure anywhere you run it and build it, those C libraries come with it, and they're already injected. And the moment it tries to actually go pull in NumPy, well, the linker is already happy. It's already seen at startup. It already loaded that C library. It doesn't have to go resolve all of that every time. So yeah, we can see there native build inputs. I'm adding auto patchelf hook. That's just so that it auto runs during the build. Build inputs is where you kind of specify the exact libraries you want in the environment, pulling it from Nix packages. And then down here at the bottom is where we actually go kind of add everything. And it actually works. So if you go and run it, I have a little dev shell that we'll have links to at the end that you can run, and it uses UV to just go install stuff really quick. It tries to make it work, and it never works every time. Reproducible failure. Everyone loves it. But if you do go patch the interpreter, what happens? Success. It just works. It can find it. Same NumPy, Same virtual environment, same UV, same everything, except a little bit of patchelf. And this is handy. This is really nice. I've been using this for a lot of my Python stuff where I do need these things, so I just don't have to worry about wrappers and setting environment variables. But it's kind of only useful for surgery in. It helps us take stuff that isn't meant for NixOS and bring it to NixOS, which is really great. Pre-built binaries, pipc extensions, stuff you find on GitHub, the latest Rust or Go project. But I wanted to see, what about going the other way? You know, like, what about surgery out? Because patchelf doesn't really care, right? It's just setting text files, it's setting keys and values. You have a lot of flexibility. And an opportunity came up. I don't know if any of you guys are file system folks, but I like playing with copy-on-write file systems. And in the Linux world, we've had bcachefs, which has been a new, fun development in this space. Unfortunately, it hasn't always been easy to use or to try. Now, on NixOS, the support has been great almost since day one. I'm running it on this laptop. I run it, for some reason, on my router at home. But, and this is no shade against Debian, but it had been kind of a struggle to get it on Debian for a while. And part of that is just, you know, Nix is happy to kind of meet software where it's at, right? We have a lot of like ways to make it safe and reproducible and dependable that maybe some of the older package systems don't really have. And so Debian's kind of having a debate, and a lot of Linux projects are around, you know, most of these modern software pieces, they're kind of developed with lock files in mind, and they're not trying to have like one version of a library that's kept in the package manager that every Python app needs to use, right? Like a lot of stuff, especially Rust projects, Go projects, they expect to have their own specific lock file per project, not per distribution. And a lot of distros are kind of struggling with that. But Nix package is totally fine. Just build it. We have great helpers for cargo, etc. So I thought, like, okay, you're never going to get this accepted in upstream Debian packaging it this way, but like, what if I have some like Ubuntu or Debian systems I would like to run bcachefs on? I don't want to have to try to build this in a build system I'm not very good at. But what do I know, at least semi-well? How to build stuff with Nix. So I tried making myself a bcachefs tools portable. And part of that is just kind of doing a similar thing with Nix, which is, hey, I know I need a whole bunch of libraries. Nix, you have everything. Why don't you provide them? So that's here. I've got some paths here. I needs Fuse, glibc, libsodium, whole bunch of stuff that Ken Overstreet set up. But after that, I mean, once we get the stuff we need, it comes time for surgery. So first of all, what do? We build the actual package. I want bcachefs tools. That's all the userland helpers that let you make a bcachefs file system, basically do anything useful with it, and it's packaged in Nix. So first thing, you just actually build that package. And then I have a couple helpers here and some bash scripts, which will be linked, that kind of go and trace through and find all the symlinks and resolve them, because often there can be several different layers of symlinks in the Nix tree before you actually go find like the actual file on disk. So once you do that, then essentially, you can go find all of the dependencies because Nix tracks it already. So you build the project, Nix tracked all the dependencies, that gives you all of the dependencies. So next up, we know that Ubuntu has its own, or Debian has its own linker, it has its own setup. That's not going to work for us. So we use patchelf and we say, actually, we're just going to ship our own linker. We're just going to bring our own dynamic linker with us. We'll take the NixOS one, bring it with us, no problem. And then we do a nice, fun little trick, which is you have that RPath. And if you remember, that's saying, where do I go look for libraries? And it turns out there's a fun magic value called origin. And origin gets set to wherever that binary is running from when it's launched. It's basically like a little way to point to like, where am I starting from? And you can set that as your RPath. So this just tells us, essentially, hey, we're going to bundle all of our libraries with us and keep them together. In this case, I'm using /user/local just as a way to avoid like colliding with anything that would be on a Debian system already. So we're going to stuff our stuff under user local Nix, and then we'll have some libraries and some binaries. So we set our interpreter to our custom one we're bringing with us. We set our RPath to go look right where our binary is, which is going to start bringing its own libraries. And then we go do some more patching to finish the surgery up, which is just to make sure that everything that we might need knows that we are going to be local. So we don't want anything looking out of the store. We don't want it trying to hunt around on the Ubuntu system where it's not going to find anything valuable. So we kind of go through, and any of the libs that we are bringing with us, we patch as well. You'll see patchelf down at the bottom just to say, hey, use origin. And what do you get at the end? You get a bcachefs tools that can actually find the stuff it needs. And so here you'll see we'll do an LDD to go take a look at what binaries it might want. You'll see the normal sort of stuff, but in particular, we no longer have Nix paths. If you go look at this on a bcachefs from Nix, those are all going to be store paths. Ours started out that way, but now they look a lot more like paths you might see on a normal Linux system, right? User local Nix lib, pretty standard. I dump a lot of stuff under there all the time. What's fun is Nix built it. I didn't have to figure out how to package it. Nix already knew how to package it. And patchelf is what made it portable. And then on the side, I have an nfpm package that can turn it into a deb file. Again, you would never do that. Debian maintainers will hate you. Don't try to put it into Debian like that. But like for my own systems, I don't need the right Debian metadata. I just need the right files. So once you do this, you get yourself a bunch of files on disk, and nfpm, which turns out is packaged in Nix, can turn that into a deb for you. And so if we just pop over here, let's see. Yeah. How's that? A little better? Okay. And if we... It should just go real fast, hopefully, because it's already cached. But you kind of see the script running a little bit. It does some cleanup. It builds the binary. It builds the library. And then ultimately it builds a package. And we've created ourselves a janky little deb file. So if we pop back over... let's see here. Right, okay. So this, I'm just spinning up. There we go. So if we, yeah, okay. So if we just spin ourselves up a quick little Podman container running Ubuntu, I've mounted in this exact folder under /app. So if we go to /app, we'll see that we got exactly what we just built. We have ourselves our deb. And so I can do dpackage-i. And now I have an actual working bcachefs. And I can even, if we go pop over somewhere that might work, we can make ourselves a little, raw.disk, little file here. And yeah, and now we can actually format a bcachefs file system on Ubuntu entirely built from Nix. So just to kind of emphasize what happened, it was the same tool. All these binaries have the metadata anyway. We were blessed from Ilko and others to come up with all of this crazy tooling to help Nix work that it turns out can do more than just make one of the best Linux distributions possible, right? It can do surgery in to bring whatever tools you need to Nix, even if it's not maybe the right way to do it. And it turns out it can be used for surgery out, to take all of the wonders we have in the Nix ecosystem, make them portable, and bring them with you wherever you are. Patchelf is really, it's setting metadata, it's writing some strings, and once you see that, you might start seeing it everywhere. So where to go from here is the QR code. I need to flip that public, I think, so I'll do that right after the talk, but there's a bunch of repos here with the things I've been playing with, and there'll be a repo for the talk as well, which has a flake to build the slides and run it. And of course, it looks like we're coming up on lunch. So if you do have questions, feel free to come find me. Happy to talk, happy to work through any of the code. And thanks for coming.